So in this video today, guys, I'm going to be going over dividing complex numbers. But by the end of today, you'll be able to apply what we have learned by multiplying complex numbers to help us divide complex numbers, okay? So dividing complex numbers, when we divide complex numbers, you cannot have an imaginary number or any imaginary numbers. You cannot have any imaginary numbers in the denominator, y'all. So you cannot have any imaginary numbers in the denominator, and that's because imaginary numbers represent a square root of a -1, right? So like we did that review lesson on rationalizing denominators, and we realized there that we couldn't have radicals in the denominator, and this is why we can't have imaginary numbers in the denominator either. So in order to simplify fractional rational complex numbers, you will need to use, yes, but we're going to say actually here multiply the conjugate, okay? You're going to have to multiply them by the conjugate. It'd be great if I could spell today, y'all, sorry. Okay? Here's our first example of a rational complex number, okay? So this has imaginary in the top and the bottom, and we can't have that imaginary in the denominator, y'all. So we're going to remove it through a process, okay? So, but first, let's review conjugates, okay? So conjugates, as you learned in the lesson M14, y'all, A minus BI and A plus BI are conjugates of each other, right? So we're going to write the conjugates of each complex number here. And remember, we only change the sign of the imaginary part, okay? So this is not going to change at all because it has no imaginary part. This is going to be -25i because we're going to change the sign of the imaginary part. This is going to be -1 minus 9i. And, oh, look at number 4. Is it in standard form? No. Okay, so we're going to change it to standard form first. Then we're going to change the sign of the imaginary part. Okay, so watch that. Okay, make sure it's in standard form and you're changing the correct part of the problem. So now, let's see how you can use the conjugate to get rid of the imaginary numbers in the denominator. So step 1 is that we're going to multiply the numerator and the denominator by the conjugate of the denominator. Okay, so we want to figure out what is the conjugate of the denominator. So this is 1 minus 2i, so we want to do it by 1 plus, okay? And remember, we're putting this over each other, okay? So now there's a couple ways we could do this. We could use the box method, right? Or we can use FOIL. So I'm going to use box here. I'm going to use both throughout the lesson. So we're going to see which one y'all prefer. I can tell you I'm going to prefer the FOIL method as I start working these problems. But use whatever tool works for you. So this is 8. This is 3i. This is 16i. And that's 6i squared, right? Noting again where our, and I'm working on the top right now. Y'all got me? So this is going to, we're looking at our like terms right here too. Y'all see that? So this is going to be 8 plus 19i plus 6i squared. Recalling that we're going to change this to -1, right? And multiply it. So that's going to be 8 minus 6 plus 19i. So this is going to be 2 plus 19i. That's our numerator, okay? We'll put an n over here. That's the top, okay? Now we have to do the bottom. Now, this is what you should remember about the bottom, okay? When we're dealing with the bottom, we can take that first term, the 1, and multiply it by the 1, which you know is 1 squared, right? And then you can also multiply the -2i times the +2i. Remember, when we do these, our diagonal cancels out, or our inside-outside cancel out. We call this sum and difference, and when we're doing sum and difference, all we ever have to do to get the answers to these is square the first term and subtract the square of the second term, okay? So this is going to give us 2 here, or sorry, 1. Having math issues today, y'all. 1 minus 4i squared, right? Recall again that we're going to change this to a negative 1, so that's going to make that 1 plus 4, right, which is 5. Now that's our denominator. So when we write our answer, it's going to be 2 plus 19i over 5. So we said combine like terms where appropriate. That's what we did. This was our answer, y'all, right there, okay? So if you do this correctly, there should not be an imaginary number in the denominator. And if you still have an imaginary number in the denominator, then you know you did something wrong, okay? Because we're trying to get a number in the denominator. All right, so let's do a couple more of these. Here's our next example. Again, we're going to put it 1 minus I over 1 minus I. So that's 5 times 1, which is 5. 5 times negative I is negative 5i. And here we go again. This is going to be 1 times 1, or 1 squared, minus I times I, okay? So this is going to be 5 minus 5i over 1 minus I squared. This once again changes to what? Yes, a negative 1, so that's going to end up being 2, right? So the answer is going to be 5 minus 5i over 2. Here's our next one. This one's a little easier. We like it easy, right? Okay, so this time, again, we're going to go minus 4i over minus 4i. So this is going to be minus 12i over negative 16i squared, keeping in mind, once again, that this is changing to a negative 1. So that's going to be equal to negative 12i. Negative 16 times negative 1 is a positive 16, right? And this reduces, right? Because both of them are divisible by 4. So this is going to be negative 3i over 4. And sometimes this is just written negative 3/4 I, y'all. All right, this one. So here's another example. So once again, we're going to multiply this by negative 1 minus 2i. Negative 1 minus 2i. Now this time, y'all, I'm going to use FOIL. I kind of like it better because I think it's cleaner, but it's your call. You can use the box method here, so it's your call. So 2i times negative 1 is negative 2i. 2i times negative 2i is negative 4i squared. That's the outside. The inside here is going to be 3 times negative 1, which is negative 3. And then we've got our last terms, right? So then we've got 3 times negative 2i, which is negative 6i. So hopefully you notice where our like terms are. They're right here, okay? And then on the denominator side, again, we're going to do our negative 1 times our negative 1 minus, well, we'll just do plus 2i times negative 2i, right? Again, you can square those. I don't care which way you do it. So let's simplify the top. That's going to give us negative 3. I'm just going to leave the negative 4i squared next to it because, you know, we're going to change that to a negative 1, and we're going to end up adding that 4. And then we got the negative 2 and the negative 6, so that's going to be negative 8i. This is going to be 1 minus 4i squared. Once again, going to change that to a negative 1. So this is going to give us negative 3 plus 4 minus 8i. And this is going to be 1 plus 4. So our answer is going to be 1 minus 8i over 5. We've got one more example, and then y'all are going to work some. So notice with this one, it is not written in standard version. So I'm going to actually write this in standard form first in the denominator, just so I don't make a mistake. So this is going to be minus 1 plus 2i, which means when I multiply it, it's going to be minus 1 minus 2i over minus 1 minus 2i. So once again, I'm going to use the FOIL method. So I'm going to use first to first. So that's 8 times negative 1. So that's negative 8. 8 times negative 2i, that's going to be negative 16i. 3i times negative 1, that's negative 3i. And then 3i times negative 2i is going to be negative 6i squared. And since we've been talking about this, I'm going to go ahead and do it. Negative 1 squared minus 2i squared. Okay? So now we're going to combine some like terms. Y'all see the like terms right here? So that's going to be negative 8. And I know that this over here is going to be multiplied by negative 1, right? So that's negative 8, and that's going to be negative 6 times negative 1, so that's plus 6. And that's going to be minus 19i. And then down here we got 1 minus 4i squared. Once again, this is going to change to a negative 1. So that's going to be equal to negative 2 minus 19i. And that's going to be 4 plus 1, right, y'all? Or 1 plus 4. So that's going to be 5. So that's our answer right there. Okay, so I'd like you guys to work each of the next ones. You can pause me between, work it, pause, check, whatever it works for y'all. So this one's pretty easy. So we're going to multiply it by 6i, positive 6i, over positive 6i, right? So this is going to be 30i over negative 36i squared. Keeping in mind, again, this changes to a what? A negative 1. So this is going to be 30i over negative times positive is what? Yeah, this is going to be 36. So then we're going to simplify this. And 5 goes into both of these. No, 6. Let's do 6. Yeah. So this would be 5i over 6, right? That's your answer. So here we go again. Then we're going to multiply this times 2 minus I over 2 minus I. So that's going to be 6 minus 3i. Keeping in mind, again, we can square that 2 and subtract I squared from it, right? So that's going to be 6 minus 3i. That didn't look much like an I, y'all. I'll fix that. Whoops. Be great if I could write, huh, y'all? And then this is 4. And remember, this is what? A negative 1. Minus and minus 1 makes it plus, right? So that's going to be 4 plus 1. So this can be 6 minus 3i over 5. All right. Here comes our fun one, right? Okay, so notice again, it's not in standard form. Y'all notice that this problem's not in standard form. So we're going to do minus 3 plus 3i over minus 5 plus 2i. We're going to multiply that times minus 5 minus 2i over minus 5 minus 2i. Okay, so I'm going to use FOIL again. First, outside, inside, last. So negative 4 times negative 5 is 20. Negative 4 times negative 2i is going to be plus 8i. 3i times negative 5i is negative 15i. And 3i times negative 2i is negative 6i squared. So hopefully you see our like terms here. Right here in the middle. These two, right? See them? So this is going to be 20. And that's going to be minus 7i. And again, we're going to change this, right, to a negative 1. So that's going to give us what, y'all? 6, negative 6 times 6, that's plus 6, right, y'all? And then over here, we're going to, again, do our denominator. So we're doing negative 5 squared minus 2i squared. So that's going to give us 26 minus 7i. And that's 25 minus 4i squared. Keeping in mind, again, this changes to a negative 1. So we're going to actually add the 4 to the 25. So our final answer is going to be 26 minus 7i over 29. Because remember, we're going to add that 4. Okay, one last one, y'all. So here we go. 2 minus 2i, 2 minus 2i. I'm going to use FOIL on the top. Is that okay with y'all? Okay, so I got 6. Outside would be minus 6i. Inside would be plus 4i. Last to last would be minus 4i squared. Again, we got our 2 squared minus 2i squared. So I'm going to do I'm going to make that a -1. Notice these two combine, so this can be 6 minus 2i plus 4, right, y'all? Because again, that -1 times that -4. And then down here we got 4, and that's going to be minus 4i squared. Keeping in mind that changes. Sorry, I'm almost sneezed, y'all. A negative. So continuing to basically combine our like terms, we have the 6 plus the 4 here, so that's going to be 10 minus our 2i. And then this is going to be 4 plus 4, right? Because that -4 times the -1 is 4, so this is going to be 8. Now this will actually reduce, y'all. So obviously everything is divisible by 2, right? So this is going to be 5 minus I over 4, and that's our final answer.